start this problem? Clear the denominators, right? We don't like this equation because it has fractions. So when we say clear the denominators, what am I going to do? I'm going to multiply both sides by x plus 1, right? Of course, over here I'll have to distribute. On the left side I get some canceling. But on the right side I'm going to have to work out what that is. So I get 2x plus 17 equals, and if I work this out I get x squared plus 6x plus 5. Those two binomials, multiply them out, give you that trinomial. Okay, next step. Sure, and also the 2x, right? Because we want to set it equal to what? Yeah, and then we can use the quadratic formula, or if we're lucky, as we seem to be quite often, we'll be able to factor. So let's see, I get x squared plus 4x, and then I'm getting minus 12. That's actually a nice one, minus 12. Does this factor? What do I get? 6 and 2, right? So we want plus 6 and we want minus 2. That's okay? So from this, I get x equals negative 6 or x equals 2. You guys follow? So I get these two solutions, but I think what I'd like to do here is I'd like to show this graphically. It helps here to see what's going on. Okay? Now, this is good practice. When I say show it graphically, here's what I mean. The left-hand side, I could call this f of x. The right-hand side, I could call this g of x. F of x is exactly the kind of function we've been studying. A rational function. 2x plus 17 over x plus 1. Right? If I were to graph that, tell me a few facts you can now identify having done the homework. The domain is everything except negative 1, right? So domain, I guess we could say we're going to go from negative infinity to negative 1 and union with negative 1 to infinity. What else can you tell me about that function f of x? Vertical asymptote where? Yeah. How do I know it's not a hole at negative 1? Yeah, that's right. Negative 1, if you put it into the 2x plus 17, it doesn't make it 0. X plus 1 is not a factor of 2x plus 17. So we do understand that sometimes we get a hole in the graph, but not for this one. Okay? How about horizontal asymptote? Do you guys have that down yet? That's right. It's at y equals positive 2. Again, I look at the leading coefficients of the highest degree term. The degrees are the same. So we have a horizontal asymptote, right? So this is good. I mean, already I can start to sketch a graph of what f of x looks like. So we sure can. How would we do that? The y-intercept, we set x equal to 0. And I get f of 0 equals, like you said, 17. Okay? While I'm at it, what about an x-intercept? X-intercept, we set f of x equal to 0. 0 equals 2x plus 17 over x plus 1. But how do you make a fraction equal to 0? Make the numerator equal to 0. 2x plus 17 is equal to 0. So there's an x-intercept where? X equals, is it negative 17 halves? Right? I'm glad you brought up the intercepts. Those are good to find. All right, let me draw a different picture. Actually, let me use the calculator at this point. You have enough information to sketch most of it. Let's do it for good practice. All right, so let's go ahead and do it. I'll move down a little bit farther to sketch it here. Now let's see what I have. Well, one thing I've been doing which has been helpful is I've been doing what's called a sign diagram. What are some of the important points I should put on the sign diagram right now? We better put -1, because -1 we know that the thing is undefined there. Why 2? Yeah, I guess on the actual graph, I'll want, if I'm going to count these by 5s maybe, I'll want to know that there is an asymptote at y equals 2, but I will tend not to do much with that as far as the sign diagram. The sign diagram is talking about x's, right? It's just the x number line. There is another important x besides -1, and we just found it. We found an x-intercept. What was my x-intercept? -17/2. So that's what? -8.5. Way over here, when I input -17/2, the output is 0. And that's important. Why? Because remember what I'm going to do in each of the intervals. I'm going to find out positive or negative. And the function is going to be continuous on the intervals. The only place it's not continuous is where it's undefined. Well, the reason 0 is important is because maybe it'll change from positive to negative at that point. Does that make sense to people? Okay? So it's time to go ahead and pick some values. Well, over on the right-hand side, why don't I pick 0? I already did that. When I set x equal to 0, what is f of 0? Well, it's positive, right? So I'm going to say on my sign diagram that once I get past this -1 point, it's positive. What about between -17/2 and -1? Give me a point to try. -2 is a good choice. Okay. So when I go to compute, for example, f of -2, I get 2 times -2 plus 17 over -2 plus 1. And I told you I don't care what it equals. All I care is the sign. The sign of the numerator is positive. The sign of the denominator is what? Negative. And so I would claim that anything in here is going to be negative. Do you guys follow that? Good, because this is what we've been doing for homework. And I will tell you, if you put in something less than -17/2, you're going to get, so say f of -10 or something like that. You're going to get a negative over a negative, which is a positive. And so my sign diagram looks like this, plus, minus, plus. And that's enough for me to get a pretty good picture of what's going on. I graphed the horizontal asymptote because someone mentioned it already. Let's graph the vertical asymptote, and that's where? X, let's see. Oh, the intercept is at 17. I'll graph that in a minute. Let me graph the asymptotes. Horizontal asymptote at y equals 2. Vertical asymptote at x equals -1. Somewhere around here, x equals -1 is a vertical asymptote. And now I'm going to graph the point that you just mentioned, Jack, this 0, 17. So I'm counting by 5s, and I'm saying that this is 0, 17 right here. Okay? And now what is the graph going to look like? Well, remember, as I move closer to that asymptote, we have to approach it. So it seems to me it's going like that. And it's going to curve down around here somewhere. And it's going to become asymptotic there. So it's something like that. What about to the left of the line? Do I know any points about to the left of the line? Well, I do. I know that -17/2 is the x-intercept. So can you get a picture of what this looks like? There it is. Pretty cool. Now, all that's in black. All of that is the graph of f of x. Now we also could graph the left-hand side, right? F of x we said is 2x plus 17 over x plus 1. G of x is going to be the function x plus 5. Well, that I know how to graph. What is that? X plus 5. What's the graph of that look like? It's a line, right? What's the intercept? We have a y-intercept of 5. And what's the slope look like? Up 1 over 1. So this is going up at a 45-degree angle, guys. Looks kind of like this. Okay? Now, back to the problem we started with. We started with this equation. And the equation was, where does f of x equal g of x? Can you see where f of x equals g of x on the picture? Where? Right here and right here. Are you guys with me? And what did we learn about those points? Well, what we did is we solved for the x-coordinates. The x-coordinates are negative 6 or positive 2. That's what our work did for us. You guys with me? So one way to do these problems would be this. I could graph f of x on a calculator. I could graph g of x on a calculator, and then just look where the intersections are. Right? Pretty nice. Not a bad idea. And not to mention, not only that, but on an exam, I'm going to want to see algebra, right? You can't show me what you're doing on the calculator. You may use a calculator on the exam on Thursday. Absolutely. I'm realizing more and more that to do a lot of what I want to do with this course, it helps to have that calculator. Okay. By the way, someone was asking me, let me pause it. So now I want to solve this problem. Let's solve the following. Let's solve, how about 2x plus 1, 2x plus 17 over x plus 1 is greater than or equal to x plus 5. Well, that's not a whole lot different from what I just had, right? So I'm going to make a suggestion here. I'm going to make a suggestion that we do this. We're going to begin the problem in a slightly different way. Okay? Instead of clearing the fractions, by the way, clearing the fractions right now, you would multiply both sides by what? I have a question for you. Is x plus 1 positive or negative? Are you sure? Depends what x is, right? We don't know. You guys follow the idea here? So I don't want to go multiplying by x plus 1 because if it's positive, I leave the inequality the same, but if it's negative, then what happens? Yeah, you have to reverse this inequality. And so what I'm going to do instead is the idea of setting the inequality equal to 0. Okay? Let's set the inequality equal to 0. So I'm going to write 2x plus 17 over x plus 1 minus x minus 5 is greater than or equal to 0. Or maybe an even better way to do it, let's write it this way. Minus parentheses x plus 5. I subtracted the x plus 5 from both sides. Do you guys follow? Now, can I write x plus 5 as a fraction? How would you write x plus 5 as a fraction? Put it over 1, right? So now my equation says 2x plus 17 over x plus 1 minus x plus 5 over 1 is greater than or equal to 0. And the reason I'm writing it as a fraction is I'd really like to subtract these fractions. Now, am I allowed to subtract these fractions? Why not? You need to have a common denominator. But you can get a common denominator. All I have to do is multiply top and bottom of this inequality by what? X plus 1. So let's do that. Let's multiply the top and bottom of this inequality by x plus 1. So, let's see what happens. I'm going to change colors here to emphasize what's going on. Will I be able to subtract these fractions at this point? Sure, because what's the common denominator going to be then? X plus 1. Okay? Now the numerator, well, it's going to be whatever 2x plus 17 is, minus whatever I get when I multiply out x plus 5 times x plus 1. Of course, I already did that up above. I remember it was x squared plus 6x plus 5. All right, I'm getting there. So now, what I'm going to get next is, let's see, 2x plus 17 minus x squared minus 6x minus 5 over x plus 1 is greater than or equal to 0. So I'm going to get, well, it was plus 6x, but now I had to do what? Distribute that negative. You see that? So that's why I kept the x plus 5 kind of in parentheses, is I wanted to remember that I'm going to have to distribute that negative. All right, so let's see where we're at now. We have negative x squared minus 4x plus 12 all over x plus 1 is greater than or equal to 0. You guys with me? One thing that people sometimes like to do here is try to factor the numerator. I'm going to do that. Show you exactly how I would factor it. Negative. Let's just take out a negative 1 to start. So what do I be left with? X squared plus 4x, and then what? Minus 12. It's funny, we're doing a lot of the same things we did in the equation. So let me move over here and kind of show you where I'm at right now. I'm at this step. I have negative and a couple of factors over x plus 1. And so let's see. Negative, what do I have? X, we did this before, what is it? X plus 6 and x minus 2. And now the question is, when is this bigger than or equal to 0? You guys follow? Now, there's a really nice reason I wanted to do it this way. I brought everything to the left-hand side and turned it into a gigantic rational function. It's a rational function. Are you guys with me? And I want to know, is the rational function bigger than or equal to what? 0. Well, we've played this game before. You know what I'm about to do? A sign diagram. I'm going to do a sign diagram. Now, what are the important points we should list on the sign diagram for this rational function? Definitely -1, because what do we know about it at x equals -1? It's undefined. Any others you think I should list on my sign diagram for this rational function? Yeah, what about 2, for instance? What happens to this rational function when you plug in a 2? It makes it 0. So I'm definitely going to put 2 because that output is 0. And I'm definitely going to put -6 because that output is 0. So it looks to me like there are 4 intervals that I want to check. You guys follow? Okay? So I'm going to check 4 intervals and decide, are we greater than or equal to 0, or are we less than or equal to 0? Okay? We won't be equal to 0. It's either going to be greater than or less than. So let's start off to the right. I always like starting to the right. Give me a number bigger than 2. 3. Okay? So let's call this rational function, just for the heck of it, let's call it r of x. Okay? If that's called r of x, then what I want to do next is I'm going to find, for example, r of 3. R of 3 looks like this. There's a negative sign, there's 2 parentheses, and there's 1 parentheses. And when I put in my 3, I can see that it's going to be a positive number here. 3 plus 6 is 9. A positive number here, because 3 minus 2 is 1. And a positive number there. Right? But, of course, I have that negative sign there. So what does that tell me about r of 3? It is what? Negative. Okay, on my sign diagram, I'm going to list that to this side of 2, we're negative. How about a number between -2, between -1 and +2? 0 is my favorite. Let's find r of 0. It's going to be negative, positive, negative over a positive. What does that equal? It's positive. 2 negatives makes a positive. So I am positive here. Who's with me so far? Nice. Okay. Next, r of, say, something like -5. That'll put me in this interval. Let's see. Negative, positive, negative over what? Negative. So this ends up being negative. Negative. And the last one, something like r of -10. Well, here they're all negatives. Negative, negative, negative over negative. And what's that give me? Positive. So in this example, the sign diagram looks like this. Plus, minus, plus, minus. One thing to emphasize about the sign diagram is that you need to check the endpoints separately. Here's what I mean by this. I'm about to list the solution set to my problem. My problem was, where is this 2x plus 17 over x plus 1 bigger than or equal to x plus 5? And all this work shows me that'll be true wherever this r of x function is bigger than or equal to 0. Are you guys with me? Now I claim that r of x is bigger than or equal to 0 anywhere from -infinity up to where? -6. And then it's going to be negative. But the reason I say check the endpoints separately is the sign diagram doesn't tell you if 0 works or not. I mean, if -6 works or not. I already know, though, r of -6 is what? 0. Are you guys with me on that? So if r of negative 6 is 0, do I want to include negative 6 as a solution? Sure. Okay. Is there anything else I should include? Union. And what do I want to do next? From negative 1 to 2. But remember I said we have to check the endpoints separately. Do I want to include negative 1? Why not? It's undefined there, so let's put an open interval there. Do I want to include 2? Yes. How do I know that it's undefined at negative 1? Well, it would make a 0 in the denominator. What's that? Oh, that's because the problem says we're allowed to be greater than or equal to 0. If it didn't say equal, these would all be open. Does that make sense? Okay. And there's one last thing to show you guys, and it's the graph. Remember the graph we drew before? This graph was for when these two fractions are what? Equal. And where are they equal? At the red spots. Well, now think of it again. That graph is supposed to represent f of x, which was in black, and g of x, which was in blue. You guys with me? And I graphed f of x and g of x. I actually did it by hand. But if we look at the picture, this problem is asking, where is f of x bigger than or equal to g of x? In other words, it's asking, where is the black above the blue? Well, you can see on the picture that when I go from negative infinity to negative 6, the black is above the blue. I didn't draw it out this far, but do you see what I'm talking about? And then, in this interval, the blue's above the black. Until you get to negative 1. Why? Because there's an asymptote, and all of a sudden, where's the black now once I move to the right of negative 1? Way up here. See that? We have f of x is above g of x until you get to where? 2. And then from there on out, g of x is greater than f of x. So that's kind of cool to be able to see it graphically, to be able to figure it out analytically, algebraically, okay, in the same problem. Okay, so this is still section 4.3. You have x cubed plus 2x squared plus x over x squared minus x minus 2 is bigger than or equal to 0, right? That's what we're trying to figure out. This one is really kind of nice because it's already just one rational function. Remember the last problem I did? The last problem I did, I had to set it greater than or equal to 0. I wanted to get 0 on one side. And then I had to put the two pieces together to make one big rational function that I called r of x. You guys with me? This guy already is a rational function. It already does have 0 on one side. This is my r of x. Okay? I'm ready. I'm almost ready for sign diagram. Not quite. Do you know why I'm not quite ready for sign diagram? There's something I want to do to r of x first of all. I want to factor it. That's right. So let's do that. Let's factor the numerator. When I factor the numerator, well, I'll take out an x, right? X squared plus 2x plus 1 is greater than or equal to 0. Oh, that's nice. And so over x squared minus x minus 2. And so I can rewrite r of x this way. Maybe I'll do it over here. I'll rewrite it as x times what? How do you factor x squared plus 2x plus x plus 1 times x plus 1, or x plus 1 squared, right? Over that denominator factor, I hope? Good. What do I get? I think it's x minus 2, x plus 1, okay, is bigger than or equal to 0. Huh. Okay. Now, it did not tell me to graph, but I'm going to tell you that you could graph that left-hand side, couldn't you? And you have to know some of those things if you want to go ahead and now do a sign diagram. So we're going to do a sign diagram. What important points do you think I should put on the number line? Yeah, Matt? Oh, yeah, sure.
Why do you cancel x plus 1?
So, yes, you could cancel the x plus 1s, but if you do that, you're going to lose a little bit of information. See, right now, I know that -1 is one of the important points on the sign diagram that I want to think about. By the way, what would be true about the graph at -1? Do you know what we would have at -1? We're going to have a hole in the graph. How do we know? Because I have a factor x plus 1 in the denominator, but I also have a factor x plus 1 in the numerator. Okay? And that's the situation where I get a hole in the graph. But see, if someone goes ahead and cancels those, they're not going to think there's a hole at -1. As a matter of fact, if someone cancels those, what would they think is the value at -1? Do you know? You do. But what I'm saying is, let's suppose someone looked at this. X times x plus 1 over x minus 2. Let me call that g of x. If they did that and said g of x is this, then what is g of -1? Isn't it 0? Right? Because you plug in -1, you get -1 times 0 over -3. That's a 0. You guys with me? So this, someone might think that the value is 0, but really there's a hole in the graph. Actually, you know what this tells me? This tells me the picture that there's going to be a hole at -1 comma what? 0. So you kind of do have to do that if you want to know exactly where the hole is. All right? Now, that's only one of the important points. What are some of the other important points for this thing I've been calling r of x? Definitely 2. How come? What happens at 2? Yeah, as a matter of fact, I mean, it's undefined at -1 also. What are we going to have at x equals 2? We're going to have an asymptote. Yep. Vertical asymptote at x equals 2. At -1, we have a hole. Are there any other important points you think I should plot on the sign diagram? I see one more. Why 0, Dan? You're right. Yeah. And in the numerator, right, think about this. What are the x-intercepts or zeros of the function r of x? Well, how do you make r of x equal to 0? You make the numerator equal to 0, right? Well, what's going to make the numerator equal to 0? Well, I can look, right? The numerator is x times x plus 1. Maybe times another x plus 1. So x equals 0 is an important point, because if I plug in 0, what's the output? 0. And that's important because maybe it'll change from positive to negative or from negative to positive in between. So I would say those are the important points on the sign diagram. You guys know what to do next? Plug in what? Points in each interval. Personally, my personal preference is I will start from the right because that gives me the most positive numbers, right? If I put in like R of 10, I would get, well, positive, positive, positive over positive, positive. Yes, I am positive in that interval. Guys follow? Why don't we do the rest? I'm going to pause for a little bit while you guys do the rest. Number 13. By the way, did we do this? Did we fill in the signs for these intervals? You did? Cool. What'd you get? Yes. Okay. You're talking about the domain, right? Negative infinity to negative 1. Oh, you know, you actually have the answer. Say that again then. For number 13? So is it worth it to finish this? Yeah. I think so. I mean, once you get... Go ahead, Abby. What I did was I said, what would happen if I actually cancel those x plus 1s? Then you get a function g of x, which is almost the same as r of x. What's the difference? The domain's different. R of x has a hole. G of x is going to be the same graph, but the hole's filled in. Do you guys follow that? What's that? Well, yeah, I guess I'm going to have you guys decide if you need it or not in a little bit. Okay? You're right. I mean, we don't need it. You know, we just did R of 10, and we worked out that everything was positive, and that's why this interval is positive. Tell me something else I ought to compute here. R of, you tell me. Thanks, guys, for all your help. This is really nice of you. Let's do 1. R of 1. Why are we doing R of 1? Because we want to know what happens in this interval between 0 and 2. You guys with me? Okay. So what's R of 1? I guess it would be positive, positive, positive over what? Negative times positive. I'm looking at the 5 factors up here. The only one that's going to be negative is when you put a 1 in there. 1 minus 2 is negative 1. So altogether, R of 1 is what? Negative. This one was positive. So right here, this interval, we're going to be negative. Why do I use the factored form? For me, it's a lot easier. I could, if you want, put a 1 in here. And I would get 1 plus 2 plus 1 is 4 over 1 minus 1 minus 2 is negative. Positive over negative is negative. I'll get the same answer. You can also use the calculator, right? That's actually really nice. Let's do it. Nice. What are you typing in your calculator? Are you typing in the very first equation? Cool. Let me do that. Y equals, and what's the problem? X squared, no, x cubed. How do I type that, guys? Oh, you did not do it in the y equals? I'm going to do it in the y equals. It's even better. X cubed plus 2x squared plus x, close parentheses. What? I really need parentheses around what and what? The numerator and the denominator, so it's going to do it right. Okay, divided by, open parentheses, x squared minus x minus 2, close parentheses. Beautiful. I'm ready now. What do I want to do? Graph it. don't know if I really like this window. If you guys are doing the standard window, your graph looks more like this. Well, I'm not sure that's much better. Especially with the bright shining light on, it's hard to see anything. But what's really nice about the graph is even if you can't see the graph, you can still do computations. Watch this. This is kind of cool. What did we just do? R of 1. If I hit second calculate and I press, so that's the trace button, the second, and it says the first choice is value. If I press enter, it's going to ask me what x do I want. I want to set x equal to 1. It'll tell me what y is. So if I plug in a 1, it says y is -2. You guys with me? And actually, I guess I can see that it's going to be negative between 0 and 2. Now, here's a question. Can you tell me what happens between -1 and 0? Can you tell? Well, let's put in -1/2. Let's do it the same way. Let's calculate a value. Let's put in -0.5. Enter. It says y is positive or negative? Positive. I'm not sure if you would see that from the graph, but if I zoom in, I'll see what's happening. It's just above the axis there. It goes through 1. See that? You can see it now. It just goes above. So it is positive here. And then what's happening at -1? I already figured out there's a hole. And then negative. Where is the hole? That's what we did with this g of x. I forget who asked me. Abby? One of the things I needed this for was to figure out where the hole was. I knew the hole was at x equals -1. I plugged -1 into the reduced function to get that the output is 0 there. Okay? So if I were going to sketch a graph showing all these features, I guess that the graph looks like this. Comes up, there's a hole here, goes through 0, 0, goes down because there's an asymptote at x equals 2. And then I don't see the rest of the graph right now. I'll have to do that in a second. I guess so far I know about this. I know that the rest of the graph is positive. But to really understand what's going on, I need to compute the slant asymptote. How do I know there is a slant asymptote? You have to look at the degree, right? The top is degree what? 3, and the bottom is 1 less. Anytime you have it 1 less, 2. Anytime you have it 1 less in degree, you know you're going to have a slant asymptote, right? X cubed over x squared. So all I have to do, guys, is divide x cubed plus 2x squared plus x divided by what? X squared minus x minus 2. All right. Tell me what I do first. What times x squared is x cubed? X. After I write that down, what do I do next? You multiply. Sure. X times all this stuff, I get x cubed minus x squared minus 2x. Next step. Delaney, all right? What's that? You subtract, right? We don't like to subtract in algebra. What do we like to do? Add the opposite. So when I draw the line, I change all my signs. And I get 3x squared, because all the x cubes are gone, plus 3x, right? I guess plus 0. What's next? You say, what times x squared is 3x squared? You'd say plus 3. 3x squared minus 3x minus 6. when I draw my line, I change all my signs. And I get a remainder of 6x plus 6, and it really is a remainder, right? You're kind of stuck at this point. Now, let me show you what I just determined. Okay? R of x, remember it equaled x cubed plus 2x squared plus x over means what? That bar means what? It means divided by. It equals this divided by x squared minus x minus 2. But what I just computed is that R of x also equals x plus 3 plus a little bit, a remainder. In other words, I actually divided these two numbers. Hey guys, let me remind you of a problem you did long ago. What is 15 divided by 2? It's 7. Well, no, that's not true. It's 7, and then what do you do with this? It's a remainder 1, but it really is, like Dan said, 7 and a half, which means 7 plus a half. 7 plus that extra 1 remainder divided by the 2. Because the 1 was never divided yet by the 2. Do you guys follow? So what I'm saying is R of x is actually equal to x plus 3 plus, what's my remainder? 6x plus 6 divided by x squared minus x minus 2. Now, do I understand this function? Not really. I have, but here's the thing, guys. As x goes to infinity, this part approaches, you probably know. What happens to this little piece of the function when you put in a really big number? It goes to 0. How come? The degree of the denominator is bigger. We've been studying that all, right? That's on my test tomorrow. This part goes to 0. And so what that means is the function R of x is approximately x plus 3 when x is big or small. And that, ladies and gentlemen, is what's called a slant asymptote. My slant asymptote for this problem that the function approaches is the line y equals what? X plus 3. Do you guys know what that line looks like? Sure. Has a slope of 1, has a y-intercept of 3. And you can actually see it. Now, when I'm near the middle, this part doesn't look like a line. This looks like that new roller coaster they're building at Cedar Point. What do they call it? Gatekeeper? You guys hear about this? Anyway, yeah, it's awesome. But anyways, that's this, right? But what's this? This is the hill, and this isn't even like the hill of one of the scary ones, because it's just a slope of 1. So this is like, you know, the Mine Ride Hill, right? Going up. But then, you guys with me? Sorry, got distracted. Anyways, once I have the slant asymptote, I can kind of sketch the rest of the curve. I know it's positive over on this interval, and I know that it's going to look something like this. Hold on. I got very distracted by you guys. What's that? Where? This one I just drew? Crossing which asymptote? The slant one or the... Sorry about that. I was trying to get really close to it without touching. Boy, Jen, I hope you don't grade my test. Right? It's getting close. You shouldn't touch it. You should get closer and closer without touching it. You guys with me? Oh, you're saying over here. It does cross the asymptote there. Yes. No, it's just that it can. But no, let me explain that a little better so it doesn't confuse you. When we say that we have an asymptote, we're talking about what kind of behavior. There's only one word I put in front of behavior in this course. End behavior, right? So what do I mean end behavior? I'm talking about as x approaches what? Infinity or negative infinity, right? So it doesn't really matter what it does here. That can still be an asymptote. All that this is telling me is what's going to happen in the long run as I move out in either direction. That's a good question, though, because in a lot of problems we don't cross the asymptote. But in this one we do. And it's good to know that you can. It's just that in the long run, when it goes out towards infinity, it's going to move in closer and closer. Or negative infinity in this direction. Cool. Shortcut. We like shortcuts, right? This was kind of a pain to do that long division. Sometimes you have to. I have to because I don't have a nice synthetic division way of dividing an x cubed by an x squared. I don't have a nice way of doing that. But I want you to remember some function that we put up here because Abby was talking about it. Remember my friend g of x? Remember that? What's the graph of g of x look like? Well, it looks exactly the same except for one feature. See, there's one I didn't do yet. Let me show you guys what happens if I do this right now. I'm going to second calculate a value. Let's throw in, how about -1? What's the output going to be? Yeah, that's what the calculator says. It says, I don't know. How come? There's a hole there, right? -1 is not in the domain of r of x. But -1 is in the domain of which function? G of x. So let's go back to the y equals screen. Let's clear this out. And let's type in, well, x. Let's put in g of x. It's x times x plus 1. Notice I need the whole thing in parentheses. And then I'm going to divide by, and I open parentheses, x minus 2. Close parentheses. Graph. I'll put the standard graph in there. It's going to look exactly the same, guys. You won't be able to tell the difference. Still looks like same roller coaster. The only difference is now I can calculate a value. I can throw in -1. 0. By the way, that might help you guys when you're trying to find out exactly where the hole is. Use the reduced function. Does the reduced function have the same asymptotes? Yeah, it's the same graph. So, if I want to find the asymptotes, let's use the reduced function. And all I really have to do now is x times x plus 1 divided by x minus 2. Right? Well, what is that? That's x squared plus x in the numerator divided by x minus 2. Don't we have a fast way of doing that one? Synthetic division. Why can I do that? Because this is of the form x minus c. You guys with me? Sort of. What do I put here? I put a 2 in that box, right? Let's do that. Because that's what c is. What do I put across the top? 1 for the x squared, 1 for the x. I better put a 0 for the constant. You guys follow? Watch how fast this goes. 1, 2, 3, 6. 6. Huh. So what does that mean? What the heck did I just do? Well, I divided. And I got that x squared plus x divided by x minus 2. What does it equal according to my work? x plus 3 plus a remainder. And I'm going to write my remainder as 6 over what? X minus 2. And all I care about is that as x goes to infinity, what happens to this piece? This piece goes to 0 as x goes to infinity. So, what's the slant asymptote, guys? There it is, right? Slant asymptote, y equals x plus 3. Now, I think I've covered slant asymptotes with you sufficiently. I'm annoyed by one thing, and that is it's a habit of mine. I start a problem. I teach you all kinds of mathematics about it. I still have to answer the question. Okay? What was this original question? No, the slant asymptote was just something you guys asked about. Yeah. Big picture. It had nothing to do with slant asymptotes, did it? What were we supposed to do on this problem? Solve this rational inequality. In other words, find out where r of x is what? Bigger than or equal to 0. How do I do it? Well, I do my work, I do a sign diagram, and now let's say, where is r of x bigger than or equal to 0? Let's write the answer. Can you tell from the sign diagram? I think so, right? What is the answer? Which intervals do I want? We definitely want to go from -1 to 0 because, right? That's where it's greater than or equal to 0. Do I want to include these things? Well, not -1. How come? Hold there. Do I want to include 0? Yes, because it says we're allowed to equal 0. Greater than or equal to 0, and the output there is 0. So let's go ahead and do that. Union with, are there any other places where this graph is positive? Oh, all right. Let's see. Union with what? 2 to infinity. Do I want to include 2? No, we're undefined at 2. We have an asymptote. So, there is the answer to the question. I always like to give an answer. Wow.